my name is Valencia Aurelia, absent 25 from Caecilia, and now I'm gonna show the enzyme experiment that I did in the past few days.
So the materials that we need are 6 plastic cups or bowls, 6 white fabrics, in this case I use used clothes, 40 ml or 40 grams of toothpaste for the alkaline, 40 ml of vinegar for the acid, 6 spoons of sweet soy sauce, tablespoon, teaspoon, measuring spoon, a total of 220 ml of normal water, 100 ml of warm water, 100 ml of cold water, and 6 teaspoons of detergent. In this case, I use Daya. So without further ado, let's get started. There will be 2 parts of the experiment, which are temperature and pH. The first step is to put 1 tablespoon of sweet soy sauce in each fabric. So we will be needing 6 white fabrics and also 6 tablespoons of sweet soy sauce. Then it will become like this. After that, I leave all the fabrics until it dries. While I wait for the fabrics to dry, I make the solution for the experiment. I had labeled each of the bowls to make it easier to differentiate. I start putting the solution in cup E, which is the acidic. I put 40 ml of vinegar and 10 ml of water. In cup F, I measure 40 grams or 40 ml of toothpaste and add 10 ml of water. In cup A and D, I pour 100 ml of normal water each cup. Then I put 100 ml of warm water in cup B and 100 ml of cold water in cup C. So here are the 6 solutions: A for normal water, B for warm water, C for cold water, D for normal water, E for acid, and F for base. When the fabrics had dried, I took the fabrics. After the solution is done, I put 1 teaspoon of detergent in each bowl and I put 1 fabric in each cup. Then I wait for 5 minutes. After 5 minutes, I take the fabric and dry it up. Here are the results. For cup F, or the alkaline fabric, I clean the fabric because the toothpaste is too thick. This is the base fabric before I wash it.
In this experiment, the enzyme is detergent. Detergent contains 5 enzymes, which are lipase, protease, amylase, cellulase, and mannose. The substrate is sweet soy sauce, that is a protein, and also carbohydrates. The product is amino acids, which are from protein, and glycerol from carbohydrates. As we know that an enzyme, or also called as a biocatalyst, is a protein compound that has the ability to catalyze. A catalyst has the function to increase the rate of a chemical reaction. The effect of temperature on enzyme performance is that the activity of an enzyme will increase as the temperature increases until it reaches the maximum temperature. The optimum temperature is the temperature at which the enzyme can work optimally. If the temperature is below or above the optimum temperature, then the enzyme activity will decrease. If the temperature is further above the optimum temperature, the enzyme will be damaged or even denatured. As I searched that the optimal temperature of the enzyme in detergent to work is around 20 to 60 degrees. In this case, we can see the result in the experiment that in warm water, or in cup B, it has less stain than the other. It is because as the temperature increases, the enzyme activity also increases. While we can see that in cup C, or in cold water, there are still lots of stain, it is because if the temperature is below the optimum temperature, the enzyme activity will decrease. Like proteins, enzyme action is also affected by pH. A slight change in the pH of the medium usually affects the rate of the reaction catalyzed. Enzymes work optimally at optimum pH. Optimum pH is the pH at which the enzyme causes the maximum reaction rate. If the pH is slightly above or below the optimum pH, the enzyme effectiveness will decrease. The change in pH causes changes in the shape of the protein making up the enzyme. Changes in pH also cause changes in the active site of the enzyme and prevent the attachment of substrate molecules to the active site of the enzyme, so that the enzyme catalytic reaction fails to occur. As we know that the most optimal pH for an enzyme to work is around 7, which explains why the most little stain is in the normal water or cup D, while the most stain is in cup E and F. It is because cup E and F are acidic and alkaline, which means that their pH is higher and also lower than the optimum pH of an enzyme. The enzyme in this experiment is detergent, and detergent is used to remove stains. Because stains are made of different types of molecules, a range of enzymes are needed to break them down. Detergent contain lipase, protease, amylase, cellulase, and mannanase. Lipase break down fats and oil. Protease work to break down proteins such as soy sauce, egg, blood, and other protein stains, while amylase break down starch or carbohydrates. Cellulase can remove microfiber on fabric, which can improve the fabric's smoothness and will remove soil without damaging the cloth. Mannanase enzyme help to break stains down by breaking down the polysaccharides made from simple sugar or mannose. Their ability to break down these compounds makes them excellent for stain removal. When the enzyme has done its job, the broken down particles can easily be washed away with water in the washing machine. My conclusion for the experiment is that detergent is used to wash off stain, but there are several factors that could affect the work of enzymes in detergent. In this experiment, the factors that affect the work of enzymes are temperature and also pH. Enzymes work the most in the optimal temperature and also the optimal pH. If the temperature is lower or above the optimal temperature, the enzyme work will decrease or even denature. And if the pH is lower or above the optimal pH, the enzyme effectiveness will decrease. So that's all for the experiment. Thank you all for watching. Don't forget to like, comment, share, and subscribe.